This PowerPoint presentation slideshow is going to be on food to microorganism ratio, the FM ratio for wastewater treatment math. As always, I claim no ownership to any of the questions or material presented in this video, as everything is sourced off the open internet. In the following slides, I will, to the best of my knowledge, present the proper formulas and the correct answers as a study guide for treatment math. If this helps you out, that's great. This is the food to microorganism ratio as presented by the State of Florida formula sheet that is given to wastewater treatment operators when they take their exam. If your state gives out a formula sheet, I recommend that you get yourself familiar with it so that when you take your test, you can find it easily and won't be scrambling around. So as you can see, the FM ratio is equal to the influent CBOD milligrams per liter times the plant flow million gallons a day times 8.34 pounds a gallon divided by the aeration tank capacity million gallons times the MLVSS milligrams per liter times 8.34. These are pretty simple. It's kind of plug and play, but there's a lot of information. You just got to get it where it needs to go. Given the following data on an aeration tank, calculate the current food to microorganism FM ratio. The primary effluent of 2.85 million gallons a day. The volume of an aeration tank is 207,000 gallons. You're going to have to convert that to million gallons. Mixed liquor volatile suspended solids, MLVSS, is equal to 2,450 milligrams per liter, and the BOD is 215 milligrams per liter. So here's your FM ratio formula. It's going to be plug and play. So like your primary effluent flow, the 2.85, it's your flow. Your volume of your aeration tank, right? It's going to get plugged in here. Your mixed liquor volatile suspended solids, MLVSS, right? It's going to get plugged in. And your BOD, right? 215 milligrams per liter. It's going to get plugged in, all right? That's the hardest part about this, is getting your numbers and plugging them in the right spot. All right, now that we got those numbers plugged in, so 215 milligrams per liter times 2.85 million gallons a day times 8.34 pounds per gallon divided by, remember, your 207,000 gallons, we converted it to million gallons, so 0.207 million gallons times 2,450 milligrams per liter times 8.34 pounds per gallon. That's 5,110.34 on top, divided by 4,229.63. And your answer is 1.208. Of course, you'll probably round that to 1.21. Given the following data on an aeration tank, calculate the current food to microorganism ratio. It's your primary effluent of 0.6 million gallons a day. The volume of the aeration tank is 1.8 million gallons. The MLVSS is 3,700 milligrams per liter. Your influent CBOD is 225 milligrams per liter, and your effluent CBOD is 5 milligrams per liter. So we have the formula, and again, getting your numbers plugged in. Your influent CBOD, all right, we have 225 milligrams per liter for your influent CBOD. Your plant flow, a million gallons a day, right? So plant flow, a million gallons a day. We have primary effluent flow, so plant flow, 0.6 million gallons a day. Your aeration tank capacity, all right? Aeration tank capacity, 1.8 million gallons. And your MLVSS, all right? So for our MLVSS, 3,700 milligrams per liter. As you can see, they gave us our effluent CBOD. That was just extra information you didn't need. Like I said, just plug all your stuff into where it goes. Now we have it plugged in. 225 milligrams per liter times 0.6 million gallons a day times 8.34 pounds per gallon divided by 1.8 million gallons times 3,700 milligrams per liter times 8.34 pounds per gallon. On the top you got 1,125.9. On the bottom we got 55,544.4. It's going to give you an answer of 0.020. Given the following data on an aeration tank, calculate the current food to microorganism ratio. So you have a plant flow of 10.7 million gallons a day, the volume of an aeration tank of 5.5 million gallons, an MLSS of 1,700 milligrams per liter, a VSS percentage of 82, and the influence CBOD of 225 milligrams per liter concentration. So we have our formula again, and if you notice, instead of giving us the MLVSS this time, they gave us the MLSS. So we're going to have to do some extra steps here to find the MLVSS to plug into our formula. Before we do the extra step, we'll go ahead and plug in what we have now. So our influent CBOD is 225 milligrams per liter. We have our plant flow of 10.7 million gallons a day. We have our aerator tank capacity of 5.5 million gallons. And what we're looking for still is the MLVSS. And after we plug all these in, we will solve for that. So go ahead and plug your numbers in to your formula. To solve for the MLVSS is equal to the MLSS milligrams per liter times the VSS percent as a decimal. So your 1,700 milligrams per liter times 0.82 gives you 1,394 for your MLVSS. So we're going to plug that in. So your FM ratio is 225 milligrams per liter times 10.7 million gallons a day times 8.34 pounds per gallon divided by 5.5 million gallons times 1,394 milligrams per liter times 8.34 pounds per gallon, and that's going to give you the answer of 0.314. So your food to microorganism ratio is 0.314. What is the food to microorganism ratio for an aeration tank with a volume of 325,000 gallons if the primary effluent flow is 4.20 million gallons a day? The MLVSS is 3,015 milligrams per liter, and the BOD is 241 milligrams per liter. So this one's set up more like a normal question. So what we're going to do is pull out our known and our unknowns to get it set up so we have all our numbers easily divided so we can see what they are. So our plant flow is 4.20 million gallons a day. The volume of the aeration tank is 325,000 gallons, which we're going to have to convert to million gallons. The MLVSS is 3,015 milligrams per liter. The BOD is 241 milligrams per liter, and we are looking for the food to microorganism ratio. So again, here's the formula that we've been using this whole time for the FM ratio. We're going to go ahead and plug our numbers in. So 241 milligrams per liter times 4.2 million gallons a day times 8.34 pounds per gallon divided by I went ahead and did the 325,000 gallons divided by a million, so we can get that to 0.325 million gallons times 3,015 milligrams per liter times 8.34 pounds per gallon, and that's going to give you an answer of 1.03. So your FM ratio is 1.03. So that was just a quick couple question walkthrough for the food to microorganism ratio, the FM ratio formula. Hopefully this helps you study and learn. Thanks.